PS1 had an iconic catalog with titles like Final Fantasy VII, Silent Hill, Tekken, Tony Hawk's Pro Skater, and Minecraft? You're seeing real footage of my homebrew demo of Minecraft running on a real PlayStation right now. And the craziest thing is that this fit in only 135 kilobytes of storage. I made this demo in only a week, and in this video, you're going to be seeing how I did it. To understand all this, we have to go back to December 3rd, 1994, when the PlayStation made its official debut in Japan. It had graphics like this, when most games looked like this. And although these graphics don't look like anything special nowadays, they were groundbreaking at the time. Featuring a 33.87 MHz CPU, 2 MB of RAM, and a megabyte of VRAM, it was considered quite a powerhouse at the time. In order to understand how PlayStation development works, we need to understand how 3D graphics on the PlayStation worked. CPU handled game logic, GTE, transforms and lighting, and the GPU took polygon primitives like triangles and quads and drew them onto the screen. But because of hardware limitations, developers had to be very creative, and I would need to be too. Ever since I was a kid playing games on the PS2, it was one of my dreams to actually have a game running on real hardware. So about a week ago, I set myself the goal of developing a game for the PlayStation, specifically because of the hardware limitations. Now I'm not a 3D modeler or animator, so I had to choose a game that would be technically impressive, but was simple enough graphically that it was manageable, and I landed on Minecraft. Real PlayStation developers in the 90s used Sony's official SDK called Psych, with dev units like the DTL-H series. A software development kit, or SDK, is a collection of tools and libraries designed to help developers create applications for a specific platform, in this case the PS1. But since I didn't have those, I needed to find an open source alternative, and I found just the right thing with PS Noob SDK. So the first thing I did after setting it up was making a small test application. After a bit of trial and error, I managed to make one of those bouncing square animations you saw on old DVD players, and yes, it did hit the corner. So now that I had successfully managed to create a small app, it was time to define the goals of the challenge. It had to run on real hardware, not just the emulator. And it had to have the core technical features of Minecraft, like placing and destroying blocks, and most importantly, an endless, procedurally generated environment. So I got started. I wrote some code that automatically created blocks, so I had a simple world to explore. Now obviously it still looked super rough, but we were making progress. The next thing I did was add placing and breaking blocks, as that's basically the key mechanic of Minecraft. After that, I added proper walking, gravity, and jumping, so now it already felt way more like a real game. But a problem I immediately noticed was that the world simply ended once we walked a bit. This was the first major technical hurdle. But before that, we added a few graphical improvements like removing the grid lines, adding simple trees, and a player hand. So in order to solve this problem, we decided to implement procedural world generation. In Diablo, levels could be generated from rules instead of hand-built every time. This worked by programming specific rules along with a random number generator. I applied that same idea to blocks, which allowed us to generate terrain as we moved, so the world could feel massive without storing a giant handcrafted level. Another trick we implemented was something taken directly from Silent Hill. The fog in Silent Hill gave it that chilling, dreamlike atmosphere, but did you know that it served a massive technical purpose? The fog hid the technical limitations of the PS1 by hiding the short draw distance, and I used the very same technique, which meant fewer polygons and smoother performance without exposing the world generating the map on the fly. So now that we had world generation, it was time to add an enemy, creepers. I used a lightweight state machine AI for creepers, basically idle, chase, fuse, explode, and dead. Then a radius-based explosion system that applied distance scale damage, so players closer to the creeper explosion would be damaged more. The next thing I added was a weapon, and after some tinkering, I managed to create a fully working attack animation and damage system. I added torches with a lightweight lighting system, so instead of real-time global lighting, which would be very heavy on performance, we simulated lighting by applying a brighter color to nearby blocks and simply fading with distance. But at this point, performance kept dropping, so I focused on 4 key optimizations. First, hidden face culling. In a voxel world, most faces are buried between blocks and can never be seen, so I stopped rendering those entirely. Second, frustum culling. Even visible geometry is wasted if it's outside the camera view, so only chunks inside the view cone get rendered. Third, chunk streaming. Instead of loading one giant world, I kept only nearby blocks active and streamed new chunks in as the player moved. And finally, time slicing. Instead of doing every expensive world task every frame, you process a small fixed budget per frame. And with these 4 changes, the game was now running roughly twice as fast in my tests. The last step was pulling in real Minecraft textures and adding a few more blocks, including lava. And at that point, there was only one thing left: finding out if this actually works on a real PS1. Up until this point, we had been running all our builds on an emulator, and although emulators are good for testing, we would only know if it actually worked once it ran on the real hardware. Unfortunately, we didn't have the hardware because I recently moved, so we sent off the files to a friend, and all we could do was wait. And he confirmed that it was working great. Movement, destroying and creating blocks, fighting creepers, day-night cycle, all of it was working on a real PlayStation. Now there were plenty of improvements to be made, like adding crafting, more blocks, and optimizing the game further, but it was incredible to see something I had made actually running on a console from 1994. The most interesting thing was how smoothly it was running. I expected there to be a major difference in performance between the emulator and the real hardware, but it ended up being almost exactly the same. It really shows that the algorithms we implemented helped with performance. The fact that all of this was possible in 135 kilobytes of storage, running on a console from 1994, was amazing. And honestly, I'm excited just to see how much further we can take it. If you enjoyed this video, please consider subscribing as it really helps the channel. Leave a comment below suggesting what you want to see me do next, and I'll see you in the next one.